Okay, so here you have a problem where you're going to have a certain amount of uh, barium sulfate. So I gave you the formula here. Can't remember if I did on the original exam or not, but I probably did. Um, but if now you can probably expect to not get that. But if you had 123.00 grams of barium sulfate, how many grams of barium would you have? Um, so this is the total amount that you have. And then in one way to do this is to see if you had, um, from the 123.00 grams of barium sulfate, like that, and you set it up with dimensional analysis. So from here, you can look at the periodic table and figure out uh, what barium is in barium sulfate, and then you would need your periodic table to do that. So, to find out the formula for barium sulfate, you might have to do that, but I gave it to you in this problem. But you'll see, looking at your periodic table, barium here, there's one of them that's 137.327. So there's one barium, 137.327. There's also one sulfur, and looking at your periodic table, sulfur is 32.06. So you could write that in, 32.06. And you have 4 oxygens. And if you needed to calculate that, using your periodic table, oxygen is 15.9994, and you could calculate that 15.9994 times 4, and you get 63.9976, and that'll be the number for the oxygen. So you can add that in. So you take that with your 1 sulfur, which is 32.06, and then your barium is 137.327, and you get 233.3846. You can only keep 2 decimal places because of your sulfur, so 233.38. So that would be what if you had, as we know now, a mole of it. You would have 233.38 grams of it. 233.38 grams of barium sulfate. But you also know that in that much barium sulfate, there's 137.327 grams of barium. So this would let you multiply and divide, like so, to get your actual amount of barium if you had this many grams. So if you just look at it, if you have, you're going to have 233.38 grams of barium sulfate to have this many grams of barium. You have, about 110 grams less than that. So you're not going to have this many grams of barium. So you can expect this number to be a little bit smaller than 137 when you do the math. So on your calculator, we're going to do 123 times 137.327, like so. And you're going to divide that by your total molar mass of barium, which is 233.38. and you get 72.376 whatever. Okay, so it looks like you have 5 sig figs that you can use, so you're going to put the 72.376 because that will not round the 6 up, so 72.376 grams of barium would be your answer. Because you get to have 5 sig figs from that, you got to keep 5 from this, and you know, so you had 6 from the barium there, so you're limited to 5 since it's multiply and divide. And similarly, a question like this is percent by mass, except it's asking for your answer in milligrams. If you have 0.2500 kilograms of 2.50% by mass silver nitrate, how many milligrams of silver nitrate do you have to have in there? So if you have 0.2500 kilograms of this silver nitrate solution, then you can start working to this problem also. First of all, if you had a 2.5% by mass, that means you would have that many grams per 100 grams of solution. So first of all, if you want to make it be simple, as in hundreds and grams and all that stuff, you could just quickly change this to grams. So 1 kilogram is 1,000 grams. And then in this particular case, 100 grams of solution would contain 2.50 grams of, in this case, silver nitrate. Just like that. And then you want it in milligrams, so 1 gram is 1,000 milligrams. Then you can multiply across the top and divide by the bottom, and see how many milligrams you actually have. So multiply across the top, and I'll just pull my calculator back over. And we have times 2.5 times 1,000 divide that by 100. Now, when you look at your answer, or you look at your problem, I think you only have 3 significant figures. Yes, you do. So your answer can be written straight up as 6,250 milligrams, because that is 3 significant figures. 6250, because that 0 is ambiguous, so it's not, it's not a sig fig. But if you wanted to make sure that it was known to be, 3 sig figs, you would write that in scientific notation as 6.25 times 10 to the third milligrams of silver nitrate. Just like that. So that way you can report the answer, in very clear terms as far as what sig figs go. Okay, and a couple more after this one, and we'll be done working most of the problems related to Exam 1 calculations.